Okay, in the last session we went through two data structures which are important. One is we looked at a set, and we looked at a super important data structure which we call the hash map. So today we will look at two more. We'll still use hash map in some of our solution. The first one we'll use is a list, and the second one we'll use is a priority queue, which is called min heap, max heap kind of thing. We have already studied min heap, max heap in the last semester. Now we'll see how to implement it and how to make it work with especially user defined classes. It's very easy to make it work with primitives like integers, floats, strings, anybody can do. But when it comes to dealing with employees or purchase orders or documents, then it becomes trickier, and we have to understand how to do that. So let's start with looking at the interface list. As I remember mentioning it to you, all these data structures, they have defined interfaces for it, and interfaces can be implemented by any number of classes. That's the beauty of this, the way they have created it. So we have the list as an interface. So I think everyone knows what is a list. A list is basically a ordered collection of elements. Now the word which is important is ordered. Now what does ordered mean? It's very easy to forget that importance. Ordered means in a list I can say get the first element, get the fifth element, get the seventh element, which I can't do with a set. With a set I can't say to a set, give me your first element. Set will say, I don't know. I'm an unordered group of element. I don't know who is the first, who is the second. So a linked list or a list in general has an ordering which is internally built. First, second, third, fifth, whatever. That's one factor. Set is an unordered grouping of elements where no duplicates are allowed. List has no such restriction. List, you can have duplicates. So it's an ordered collection and it does have duplicates. So whenever you have reason for storing two employees with exactly the same data, you can't do that obviously with a set. You need to employ a list because you can't have duplicates in a set. It will refuse to add. So it's an ordered collection and it has ability to store duplicates. Now what we'll do is we'll take two kinds of list and work on it. Now before we do that, let's just look at what are the important methods in a list. But as we are doing that, so these are the various kinds of classes which implement a list. Now as you can see, there are many people who implement a list, out of which two are used most. One is the array list and the other is a linked list. Another interesting thing for some of you would be the stack. The stack also is a list. Only thing is, instead of being an unrestricted list, it is restricted in terms of push and pop. So the only three methods are popular on a stack. They are push, pop and peek. Peek is just to look at the top element without retrieving it. And obviously you have other methods like isEmpty, all that. Those are anyway always there. So array list is one implementation. Linked list is another implementation. Now when do I use array list? When do I use linked list? Pretty obvious. Array list is when I want speed and I am sure that I won't be adding elements in between. So if I am going to do a lot of insertions and a lot of deletions, then array list is not your data structure. You should be using a linked list. Array list is when you want speed and you are confident that you are not going to do insertions and deletions at the in-between, because it will spoil the performance of an array list, because array list internally will be using an array. So you know an array, if you insert in between or delete in between, you'll have to push elements aside or pull elements inside. That is going to slow down. So array list is good if you just need performance and you're not going to do too many insertions and additions, except at the end. Appending is not a problem. But if you're doing in between, that's a problem. If you're doing that, don't use array list, use a linked list. That's why these two different data structures are used for list, array list or a linked list. So let's just quickly look at the methods which are available on a list. I will look only as usual at only the important methods. So the methods, if you see at the top, first is the add method, which is to add an element to a list. It's obvious. The second method is often very useful. Add at a particular point in a list, because remember, list is a ordered collection. So there is this idea of first element, second element, third element. So you can insert an element or add an element at a particular position in a list. Like you remember, we have done problems in linked list where we said insert an element after the third element. Now you can do that with a list by using index and element. So it is used. Add all is to add another list to this list. Again, I will not go into all methods. Clear is definitely a method which is used to empty the list. Contains, I think you have seen contains earlier also. Contains is just to check a presence of a particular element in a list. So we can see whether a particular element exists in the list or not, and use that. Equals is to equal. Now the super important method, I think you would have guessed, is the get method. Add method and the get method. Get is to, given an index, it will give you the value at that index or the element at that index. So that is the beauty of get. Now if you see get with map, it's very similar. There we use a key and we get a value. Here we use an index and we get a value, because there is no key value here. It's index and value. So get is very useful. Then other useful method is index of. So given an object, you want to look it in the list, you can use index of. Either if the element is there in the list, it will return the zero based index. If it is not there in the list, it will give you a -1. So that is what you could do with it. Then is empty, I think, is self-explanatory. Iterator, this was old Java. Nowadays nobody uses iterator, they just use an enhanced for loop to go through elements in a list. Last index of is very good. Same thing as index of, only thing is starts looking from the end of the list. One is left to right, other is right to left. Again, I must say here that unlike strings, where the left to right and the right to left will change based on the language, because if you're using Arabic, left to right is a different connotation, right to left has a different connotation. The natural order in Arabic is right to left, right? And so that doesn't exist with a list. List is always left to right. Last is always right to left. So that orientation issues don't come with a list. List iterator I have never used, so you don't need to use. Remove obviously is there. Remove both. Remove using an index and remove a specific object. Both are good. Both are useful. Then going down. Whether a remove is successful or not, you will know by the return value. Remove all, you want to take a bunch and remove them at one go. Not very useful. I haven't used it. Replace all, not useful. Go down. Retain all, not useful. This is a set. If you want to convert the list, this is not that. This is set. Set means update. At a particular index, it is not removing, it is not adding, it is updating the element at that particular index. So you give the index and give the value and it updates. So size is obvious. The granddaddy of all the methods is sort. This is very powerful on a list, because list being an ordered collection can be sorted. A set can also be sorted, but that is done in the insertion itself. A list, often we create a list, as we'll do today, where we just create a list as it is, and at some point we sort it. Now, sorting of an array of strings or a list of strings, it's trivial. It's in order, correct? But if I say sort a bunch of students, how will you do? Now for that you need to write a comparator, or you need to make student implement the comparable interface, one of them. We'll see all of that today. So we need to understand that very closely, because if you can't write a comparator for a list, you are no good as a developer. You are a zero, because whether you are using Python or you are using Java or you are using C++, all the time we use lists, but we want the list to be sorted in a particular order, in a specific order. And often these lists are not trivial, like list of integers or list of strings. They are often complicated lists. So we need to figure out how to sort them and write the logic for sorting. So just keep this thought with you. So today we'll learn how to write comparators for some problems, and we'll use some of them. Sort is very crucial along with the comparator. Sublist I have never used, forget it. ToArray is to convert a list into an array, sometimes used, rare. Okay. Well, that's it. So those are the methods which you see on a list. Common methods: add, sometimes add at a particular index, set to update, get to retrieve the value, sort obviously to sort. These are common, index of and last index of. These are the common methods. All the rest are decorative. Now they are useful. Obviously they are there for a reason. But in all these years of programming, if I have not had occasion to use them very often, then I don't think you will need them very often either. So, okay. So that is all. Those are the crucial methods of a list interface. And today we will start working with lists. First, I will work with list of strings, just to give you a brief example. And after that, we'll work with list of students and understand what are the consequences of working with list of students and how careful you need to get with list of students. That's the more important one, and that's where you need your own custom comparators and all that kind of stuff. Okay, so let's start. Yeah, we'll have to open a practice question for them. Day 20, practice 1. Please open that question. There's nothing there. Okay, we are going to use it to understand how to work with list, and then I'll give you an example, and let's see how many of you do it. Okay, we'll start. Import java.util.star. Class will take list demo. We'll call this class list demo. Okay, I am doing first a very trivial class just to get us used to it, and then we'll do a more sophisticated example. Yeah. Yeah. So what we'll do is we'll just create a list. I'll just show you how to create a list of strings. Just add and remove a bit, and so list of strings, that's how you do it. You know the generic way. Now here, because there are no two things, key and value, there's only one. So you obviously have only one thing in the angular bracket. That should not surprise you. So list string ls is equal to new array list. Again, I don't have to give anything there. Just a blind angular bracket is good enough, and we have the array list. Yeah. The class which contains main should be the name of the file. Okay, fine. So list string ls is equal to new array list. Done. We created an array list of strings. Now I hope you are clear about the implementation. On the left side we have an interface reference. On the right side we have a object, right, which we created using new. Object obviously has to be of a concrete class, which could be either array list or a linked list, depending on what your requirement is. Okay, so we got that. Now we'll just create a very trivial class of strings. How do you add strings? Just say add, and that's how you get strings. ls.add. Yeah, just add. ls.add. Okay. We'll add 3 or 4. Yeah. So you know how to add. This is how you add elements to a list, since it's a list of strings. Now if I try to add an integer, it's going to give me a compilation error. We'll just add it for the sake of adding it, because that's the beauty of generics, isn't it? You add any other data type which doesn't match with its pre-designated data type, it shouts, right? It says, no, I won't accept it. Remember, the old Java did not have generics. They just used to say list L is equal to new array list, end of story. No type creation. That would allow anything to come onto a list, but that would be disastrous, because caterpillars would sit on the same list as integers as humans, right? And we wouldn't know what to do with it. It would be very confusing to deal with. So this is very, so let's just try to add rather, ls.add 5. Now it's going to give a compilation error on that line, and okay, let's pretend that we have been successful. So we can do okay, we'll just do a print on a list, and then we'll show an iteration on a list. Okay, if we try to compile it, obviously we are going to get a compilation error. The compilation error is on that line ls.add5, because int can become an integer, and integer will not be accepted on this list, because this list is intended to be a list of strings. So we are not allowing that to happen. That's the benefit I get from generics of Java, because this was a not recent, it was added in Java 5, that they said, no, we want typed data structures, we don't want generic data structures. They are still supported, but when you write a program with those generic data structures, which is just list, you get an error, you don't get an error, you get a warning of deprecation. Deprecation means basically this feature is going to be phased out, don't use it any longer. Okay, so that is called deprecated. So ls.add5, you have that, and you are getting an error, you know why, so let's get rid of that, and we can print the list as at one go. Just you can do that in any language. Yeah, you can. Yeah, so as you can see, the list does not come in any particular order, or it comes in insertion order, which is not guaranteed. So it's not sorted by anything, it is not done any thing. So now let's try to sort this list and then iterate through it one by one. Iterating means going through the list one by one. So sort it. So you say ls.sort, or do you have to say collections.sort? Yeah, that is a better way. There is a class called collections. It has a static method on it called sort, which is what we use often rather than the specific operation on a list. This is more generic, and most programmers will use this because this works on arrays, this works on many other data structures which you would create. So this is what we prefer rather than saying ls.sort. Okay, this is what is preferred. So now if you sort it as expected, the data comes in lexicographic sorted order, no surprises there. So this is how you work with a predefined list of objects, list of predefined objects, which is strings, integers, all this will work. Are you with me? Okay, now going forward. Yeah, so now what we are going to do is we are going to say we are going to create a class. Before that we'll just do an iteration through a list. How do you go through all the elements with a list? So let's say all the elements which are less than 4, I don't know what are the names, 5. Okay, all the elements whose length is less than or greater than 5, I want to display. How will I do it? So I'll say for each string s, in ls, which is a list of strings, I will do some filtering. I'll soon introduce filter and all that. if s dot length is a method. Yeah. If s dot length greater than 5, then we want to see it. Okay. System.out.println. S. Okay. Some code. Okay. Yeah. So let's see what we get. Okay, as expected, we get the answer as Chandar, because that's the only guy whose length happens to be greater than 5. This is just to show you how do you iterate through elements in a list. That is called the enhanced for loop, and I am sure you have seen it before in arrays. Same thing works with list. So we just say for each string s in ls, do whatever you have to do for that logic. Okay, fair enough, trivial. Okay, now let's come to the crux of what we are going to discuss. Now let's talk about employee class. That is, we are going to create a bunch of employees or students, put them on a list and see what we can do and what care you need to take. That is what you need to understand today. Okay, so we are going to create a class employee, okay, with a few fields and a constructor. So int maybe usual e number, float salary, and string name. Then we'll write a small constructor which is used to initialize it with 3 parameters. Okay. So it takes 3 parameters: int e, float s, and string n. Yeah. Okay. And then I use it to initialize. E number is equal to e, float sal equal to s, and name is equal to n. I've initialized it. Okay. I think I'm happy with that at the moment, and we'll see what else we need to add, and we'll add it as we go. Okay. So we are going to create a list of employees now, and we are going to add elements to it, and we will see what works and what doesn't work. Okay, and slowly build up our skill set for dealing with list of objects. Please be very careful. Try and understand everything that we are doing. It's super important. Okay, so we have created a class now. Yeah, so we'll create it as ELS. Call it ELS. Let's get rid of all this. Okay, you can do it there. ELS.add new employee. Fair enough. ELS.add new employee. Remember, we need to instantiate an employee and add it to the list. So with a certain employee number, employee name, and salary. They come in that order: number, salary, and name. Okay, number, salary, and name. Okay, that employee. Okay. Yeah, first is correct. Order is correct. First is number, then salary, then name. Okay, now add one more. I add actually 2 or 3 more. ELS.add. ELS.add new employee. We are adding 3 employees. Okay. I think 3 should be enough to play with. Is that okay? So we are added 3 employees to the ELS. Yes. Now just observe what methods will work, what methods will not work. Okay. Okay. Let's try one by one each method and see what we get, and then keep on enhancing our employee class to make it a nice class which can sit on a list. Right now, our employee class is a very ugly guy. He just has data and constructor. He's not fit to sit on a list, right? We'll see why I'm making this statement. So now I am going to use the same thing. I'm going to try and iterate through a list. So for each employee E, watch carefully please and understand what you're doing. For each employee E in Arraylist, that is ELS, okay. Now do an SOP on E. Okay. Now I'm trying the same thing what I did just now with strings, correct? I took each string and tried to display it in the list. I'm doing the same thing. Now what is it going to show? Very good. What is it going to show? You know what is missing, right? Right now if I print, it is going to show me class name at hash code, because that is the default printing of an object. I have not changed it. So that is what it is going to show me. It is going to say this is the class name and this is the hash code. Hash code obviously will change for every object. Every object in Java will have its own hash code, so it will show that. So now I'll get absolute gibberish on my screen, kind of gibberish. So let's get that first. And oh, there is some error. Brackets, huh? Okay. Okay. So let's see the output. Okay. As you can see, the output is what you got. No, yes. Class name at hash code. Because this is how any object, user-defined object, is going to get printed if I create it that way by just writing a class fields and the constructor. That is what I get. Okay. Now, in order to get a sensible output, first, what do you think our sensible output should be? At least a name and maybe number, salary and name, number, salary. In that order, I should get for every employee. That is a sensible output. Now, in order to get that, okay, let's say, go back to the code. Yeah, in order to get that, and let's say, come down. I'm not going to change line 20 or 21. I'm going to still print it like that. What is it that I need to do? Override toString. Beautiful. So I think we talked about this earlier. So we need to override the toString method of a class. Because why toString? Because you remember, just like Python, we have those methods which are used while printing the class. Okay. So we have this toString method which is used by Java while printing an object. So no, can you go back? Now when I am saying println on E, Java will look for a toString method on the class to which E belongs. If it doesn't find one, it will use a toString which has come from the object class from where everybody is derived. The primordial object class is called object, and every class is derived from it whether we like it or not. So if we don't write a toString method, that toString method will come. And what will that toString method do? It is built to print class name at hash code. So that is what I am going to get, and that is what I just got, because I don't have a toString method overridden, and so the object class toString is coming into play. I need to override it. Now when I am overriding something, can you go up? Okay. When we override something, it is very common, not necessary, but very recommended to put the override tag annotation. This is called the override annotation. Why do you think it is a good habit to put override annotation? Anyone? This annotation is a good habit, but it's not necessary. I can write the toString method without this annotation also. But it's always a good habit to have this. Why am I saying that? For those who read the code. Other than that, one advantage I will agree is for reader friendliness, that this is an overridden method, good habit. But why is it otherwise a good habit? Anyone? No? Okay. See, when I say I am overriding something, what Java will do is, it will look for a method. Overriding means what? I am not writing a new method. I am overriding an existing method. So, the signature of the method, signature means what? Name of the method, return type and parameters must match some inherited method's signature. If I put the override tag, then it will check whether there is really a method in my inheritance hierarchy which is a similar toString with the exact name, exact parameters and return type. If I don't put the override and make a problem, make a change in the override signature, then Java will say, okay, you didn't say it was an overridden method, so I didn't go and look in the hierarchy whether there is already a method like this which you are overriding. Your intention is to override, and you are forcing Java to really check whether it's an overriding method, not a new method. Otherwise, it will turn into an overloaded method. Right? I don't want overloading to be confused as overriding or vice versa. So, in order to prevent that, now Java will go and check that for that toString method in the base class, and the signatures must match if I put the override tag. If I don't, then what will happen? If my signature match, it is overriding. If it is signatures don't match, it becomes overloading. If I don't put that annotation. So, it's very good habit to put this annotation, because when your intention is to override, you throw some burden on Java, you go and check whether I am genuinely overriding or not. And if I am not, let me know. Okay, for doing that, let's go and examine, because this is very important, you should know. Let's go and look at object class. Let's look at the signature of the toString method. Okay. So, object toString. You can also look. Yeah. Okay. So, this is our class string. Okay. Let's go to object class. Come down. Let's examine the methods. So, yeah. So, you can see that there is a method called toString. Can you see that? Now, let's say I add a toString. Let me just show you adding a dummy toString for a moment with, let's say, a parameter. Okay, let's now, what is the signature of the inherited method? String toString. Pretty clear? Okay. So now let's look at the method. Let's go back to our code. Method is public, by the way. Okay. So it has to be public. Let's do, okay, say public string toString, and for the sake of example, let's just add a parameter there, int p. Now, will Java accept it? Because of what? Because of the override tag. Okay. Now, observe. We'll write an empty method. I don't want to write anything inside the method. That's not important. So now, just try to compile. It won't compile because I have put the override tag. Okay. Watch and reach your conclusion. I'll try to compile it. Please try this. All this is important. Okay. Now, you can see there. Can we make that bigger? Yeah. I am claiming to override, and I have given a signature of a method which does not override. Okay. So I have kind of tried to fool Java into thinking I am overriding. What did Java do? It went and searched in its base class, which in this case is object. Because if you don't give a base class, it is always object class. It went and checked in the object class, is there a method with the same signature? It didn't find one. And because it didn't find one, it is saying it's an error. Now, I will do it little differently. Now, I will remove the annotation. I will remove that annotation at override. Now, what will happen? Will Java be happy? Yes. Because what will Java do? It will create another method. It will say this toString is also there, that toString is also there, that toString doesn't take parameter, this toString takes parameter, so it becomes overloaded. Beautiful. It becomes overloaded. So my intention was to override, but because I gave a wrong signature, it said, okay, it is now, I will treat it as overloading. Another method, name is same, parameters are different, which is fine. One inherited, which doesn't have parameters, one created here, which has parameters. I have no problem. It will compile, which is not my intention. My intention was to override that toString, because that is the toString which is called by system.out.println, not this toString with parameter. That toString without parameter, because it works on all objects. So now my compiler will feel happy. Okay, we'll compile it. No, this is another error. Extra bracket. And return statement. Yeah, return statement is KMIT. Okay, so that is why it was giving error. Okay, run it, compile it. Okay, it compiled. Yes, no? Did you understand? So it's always good when you are overriding. That is the moral of the story. Whenever you are overriding, make your intention clear. I want to override, by putting that override annotation on the method. Okay, we'll go ahead. Okay, now we will remove the excess parameter and we will put the override tag, making our intention clear that we want to override the derived class, base class method, sorry. There are many such annotations. We'll discover them as much as we can now, if not now, later. Okay, so so now the toString method I need to supply for my class. So I need to say, for our employee class, when println is called, which is toString is called, what should it do? Okay, just like in Python we had the REPR, remember REPR, which we use for changing the internal representation of an object. This is cousin of that, right? First cousin. Okay, no, I don't know. So toString will return a string, return. It has to return a string, return. First number, e number equal to e number plus space plus sal equal to plus space so we got that going. Now if I look at my code, and I hope all of you are doing it, otherwise it's futile. For employee E, so we have written the toString method to be more nice and do all that. So now come down. Okay. Now for employee E in ELS, system.out.println E. So I am going to print every employee object. The moment we print an object, what happens? Automatically the toString method on that object is invoked. It happens behind the scene, and the toString method, whatever it returns, that gets printed. So let's demonstrate this and see what we get printed. Instead of class name at hash code, we should see now a much more sensible output as we are seeing on the screen, right? Everybody understood what we are trying to do and what we did? So now we have achieved the ability to display our objects using system.out.println. We can iterate through our list just like you can iterate through a list of strings and print every object. We added the println. We added the toString method. Please concentrate. I am making a very important point. Now we have public string toString. The method in the base class was also public. We just showed you. In the object class was public. Now, what would happen if instead of writing public, which is exposed to the whole world, I made it package, which is available only in the package to which this belongs. Okay. So I remove the word public. My question will this be fine? See, it is public in the base class, and in the derived class, it is no longer public. It has become package access. So my question is Java fine with this? No. Java is not fine with this because there is a golden rule which we violated. The derived classes can only extend the access, not reduce the access. We can broaden the access but not reduce the access. Please remember this. This is what I call the nuanced Java, where you have to be very clear that, in the base class, if I have a method which has a certain access rule, then in the derived class, I can broaden it, but I can't narrow it. I can be more generous in the derived class. I cannot be more restricted in the derived class, which is what I am trying to be here. It is public in the base class, and in the derived class it is package. So I am restricting its access to the package. I am not allowing it to be available for outside consumption. So Java says, no, I am not going to allow that. If a method is overridden, then it must retain the same public access, which is public, or it can broaden. Of course, in this instance, you can't broaden because the most broad access is public. Okay? So you can't broaden it, but then you have to retain it. You can't reduce it. You can't reduce the visibility. That's a golden rule. Okay? So if I try to do that, it won't work. This is in general, not only for this. This is a general rule for any method in a derived class. So public. Okay. It won't work otherwise. Okay. Now I'm going to get a little more ambitious. What I'm going to do? I'm going to try and sort my employee objects which are sitting in a list, right? And okay. So now I'm going to say, first I'm going to say sort, or maybe I should print them first, and then let's sort them. After line 26, collections.sort. I told you I like this sort method. Collections.sort, ELS, comma, no, nothing, no comma. Okay. Now will it work? Should it work? Should it work? No, it shouldn't work. Common sense tells you it won't work, and it shouldn't. Why? When you say sort, whenever you use the word sort, please be conscious of this word sort. It's a big word. What is sorting? Means some kind of predetermined ordering. One guy less than the other guy less than the other guy, either ascending or descending. So sorting requires an ability to distinguish whether I am less than somebody or I am more than somebody. Because otherwise sorting can't work. Sorting is a mechanism to order elements based on some criteria. Whatever the criteria may be, whatever you choose to have as the criteria. But there must be some criteria on the basis of which the elements have to be ordered. Now, for our employee class or employee objects, have we ever tried to give a criteria? Have you ever said, when do we say one employee is more than another employee and he is more than somebody else? How do you say that? And sorting essentially is not possible unless the criteria is established. I have not established the criteria, how am I going to sort? It will say, I can't sort because I don't know how to sort. I don't know how one employee is less than another employee. I have no logic, no mechanism to judge. So let's try that. And let's get the error and then resolve the error. Okay. Now it said it shouted at us. Okay. So let's hear it. No suitable method was found for sorting a list of employees, point blank, right? I don't know how to sort essentially. So are we all clear why we got this problem? Yes? No? Yes? We know why we got this problem, right? Now what is the way out? Yes, there are two ways out, okay? A generic way and a specific way. Let me first talk about today you have to understand both, okay? Let me talk first about the generic way. In general, let us have a policy for employees to be sorted, in general. Then we'll get into a different ordering and we'll see how to give a different ordering. But prima facie, at a first glance, how do you say one employee is less than the other employee? Let's establish our condition or criteria for that. What do we say? What do you think is a criteria? So we say if my salary is less than your salary, then you are more than me. If you do ascending order sort, I come less, you come later, right? If you do ascending order. Okay, so salary is our default criteria. Okay, let me broaden the question a little more. If the salary happens to be same, then how would you like the data to be sorted? Yeah? Name. Age is not there. Okay? Name, correct? Name would be a good order. In ascending order or lexical order of name, if salaries happen to be same. Otherwise it is salary. Is that a good enough criteria? Because when you establish criteria as a computer science person, you have to be careful to establish the criteria in a non-ambiguous way. Ambiguous criteria doesn't help us because we are people of precision. So we have to establish the criteria of equality. If it is equal, what do we do? If it is not equal, what is the criteria, right? So the broadening of that criteria is, what if salaries are same and names are same? You will say, does that happen? Well, as I said, in the science of the precise, it happens. Well, then you say it happens on roll number or employee number, correct? Then the guy with the lesser number is lesser than the next guy. If name also happens to be same. Remote chance, but it is still in the realm of the possibility, right? So we can write the criteria whichever way. Let's restrict right now to salary and name. First based on salary, and if salary happens to be same, then on basis of name. Let's try to write this criteria using a natural ordering. And if you change the ordering, we can do that also. We'll see that in a moment. But first let's write the natural ordering. Natural ordering of a class happens when an employee class implements a very popular interface called as comparable. There is an interface supplied by Java, not by anyone else, but by the language itself. That interface is called comparable. So just go up, watch please carefully. Go up. There only. Yeah. After the override method, after the Tostring method. Yeah. Now I'm going to write, before that I need to declare which interface I want to implement. This makes me comparable. If I implement this interface, then I become comparable. Okay? So I go up, class employee implements comparable. Comparable is a standard interface which is available in java.util package. As I said, it's a standard. So comparable. Now normally you say comparable on employees, okay, but doesn't matter. I think it will allow this to happen. Okay, so class employee implements comparable. Now let's look at the documentation to check what this comparable animal is, what kind of interface it is. Okay, what are the methods in that interface which I have to implement. So let's look at the comparable interface for a minute. Please learn to look at documentation also, because that's how you learn. Okay. Now we have interface comparable with the T standing for the template or the generic. You can say it's employee, but you can say just angular bracket also. Okay, so doesn't matter. And we are writing comparable. Now see the methods in comparable, there is just one method, come down. So many guys are comparable, so that's why it's a big story. Okay, but there is only one method. The name of the method is compare to. Yeah, and it takes the same kind of object as on which we are created. Okay, so compare to, that's the name of the method. And another thing you should notice is it returns an int. Okay, okay, now we are going to write this method, and please watch it very carefully with all your focus and attention which you can muster. Let's write it. So it returns an int. Is it a public method there? Of course, we are allowed to make it public even if it isn't public, because we can broaden. Okay, public int compare to, and in our case it will take a parameter of type employee, because we are going to compare two employees, E. Okay. Okay. No, yes. Are you understanding what I am trying to write? I am trying to make my class comparable by implementing the comparable interface. If I have to implement the comparable interface, I have to give a body to the compare to method. Okay. Now, please think a little about this method and try to analyze. Now, if you see the method carefully, it takes a parameter, right? What do you think is the parameter? Another employee object. Now, every employee object has to be compared with every other employee object for it to be decided whether I am less than somebody or I am more than somebody. I need to be compared with any other employee object. So, the way the compare method is called, or compare to is called, it is called on one object passing another object as a parameter. So, when you add elements to a list, or when you ask data to be sorted, it is going to take one element, one employee, and compare it with everyone else to decide where it fits, correct? So, so it is like you have one employee object, and you are now going to compare it with one, then you are going to compare it with the next. So, the second object which is passed to it here is what is the parameter. So, please understand the parameter. Parameter is the other object with which this object is being compared. All two people have to be compared. So, if there are 10 people, there have to be 10 C2 comparisons. Would you agree? 10 C2 is that combinatorial. If there are 10 people, each guy has to be compared with other. How many comparisons need to happen? 10 C2? You agree with me? 10 C2 comparisons have to happen. Now, while comparing, we take a pair and compare. This guy and another guy. Again, then this guy and another guy. Like that. So, the another guy is the parameter. This guy is the current object. So, it is passed another object as a parameter of the same type. So that comparison works. And if I am less than the other guy, now please understand this rule. If I am less than the other guy, that is I should come earlier in the ascending order, then I should give a -1 when I am compared with the other. I should have a logic to say a negative number, not necessarily minus. I should give out a negative number if I am less than that guy. I should give out a 0 if I am equal to that guy, and I should give out a positive number if I am more than that guy. You are with me? If I am less, I should give a negative number than whom I am comparing with currently. Who calls this comparison? Java will call it internally between everyone. But I have to decide with reference to that guy, am I lesser or more? If I give out a negative value, I am deciding that I am lesser. If I give out a 0, I am deciding I am equal. If I give out a positive value, I am more than the other guy. Okay? So let me write the logic. See whether you make sense of the logic. Okay. if sal means my sal, current object sal, is equal the other guy's sal, E dot sal. If my sal is equal to the other guy's sal, then remember, if salaries are equal, we said we are going to judge based on names. So there is a nice compare method available in strings, because name is a string, which I can use. The name of that method is compare to on strings. If you want, you can go to strings. There's a nice good compare to method available on strings to judge whether one string is less than the other string or not, which I can use now. Because now, if the salaries are same, I want to compare the names of the people. So how do I do that? So you can see that there is a method for that. The compare to on strings, if you want to see. See that. Compare to with another string. It does a lexicographic comparison. This is a method in the string class. So why am I talking about this method? Because I am going to compare names, and names happen to be strings. So that's why I am doing it. So let's write this. So I'll say if salaries are same, only if salaries are same, then I'm going to return whatever is the result of the comparison between the two names. So name dot compare to, name is a string, compare to E dot name, whoever is lesser. Lexicographic comparison amongst names. So name E dot, name dot compare to E dot name. I hope you are not getting confused. Okay. If sal equal to E dot sal, then return, then I am going to compare names. Am I okay with this? This is what we decided as our policy. Else means what? Salaries are not equal. Then what should I write? Wait. What should I write? Salaries are not equal. What should I write? Sal minus E dot sal. If I am lesser, it will return a negative number? No. That's what is the intention, no? So return sal minus E dot sal. Do you agree with this? If my salary is less than the other guy, will I not return a negative number? This is what you want now? No, yes. My salary is less than yours, I should come earlier. If I have to come earlier than you, I have to give a negative value. If I have to come after you, I have to give a positive value. Okay? So, now that's it. This is a comparative method. It is written as part of the comparable. Now we are assuming that salaries and names both are not equal. Both are not equal. Okay? We are not being so narrow-minded as that. Huh? Int, no? Are we returning int, no? Acha, oh, good. Yeah, there is a small correction there. Sal happens to be float, so I will return a float. No, I can't return a float compulsorily because I can't change the signature. I have to return an int. So I will have to cast the answer into an int. Now you will ask, one of you should ask this. Suppose his salary is 45.45 and his other guy's salary is 45.35. If I cast it into int, what will happen? It will be treated as 0. No, yes. So I have to be careful. Did you understand what I said? Because it's in float that the variation in the salary, if it is happening only in the float, when I translate the answer to int, they will become equal. Unfair. But anyway, let's keep that. We'll leave it for another day where we talk about, there's a very big topic, okay, where we talk about what are the problems of FPU, floating point units, and how quantization of floating point into integers creates another set of problems. That's an interesting area. Anyway, not for today. So we do compare to, we do first comparison on salary if they happen to be same names. Otherwise, the guy with the higher salary is considered more and the guy with the lesser salary is considered less. So let's give it a shot whether now are we able to sort our employees. Collections dot sort ELS, whether our compiler will get happy with this. Okay. Now there is still an error. Employee is not and does not override compared. Okay. Sorry. Compared to the generic form of compared to is not employee, it takes object as a parameter. I'll correct it a bit. I'm sorry. So, line number 15. We don't get an employee as a parameter. The signature is changing and it's saying you have not implemented this method. So, we should say object E. Let's keep it as object, or we will call it object O for a moment. It is a generic method inherited, so it will not have employee in it, it will have object in it, isn't it? We goofed up. It's coming from an inherited comparable class, which is a generic class. How can it be employee oriented? It has to be object oriented, based on object. So object. So what will I do? Cast it. Because we know object is not going to be passed, employee is going to pass, it's a good cast. So you can blindly cast it, or there are some people who don't blindly cast. What if employees are compared with caterpillars? Caterpillar is also an object, correct? Will people compare employees with caterpillars? It's unfair, no? They don't have a salary, they don't have a name. So will they be allowed? Now in our case, it won't happen because we are comparing in a list and the list already has only employees. Now, what we'll do is we'll do a blind cast. We'll say employee E. If you don't like that, if you don't like this blind cast, you will check if O instance of employee, then cast it. That is the pure way of writing that code. The classic way of writing that code. If you look at classic programmers, they are very particular. If O instance of employee, then only I will cast it. Otherwise, I will not cast it. First confirm, then cast. We are very trusting people, right? So we will cast it. Employee O. We are casting O into employee because we know it is an employee in our case, present case. So now the compiler should feel happy because the signature of that method. Actually, we should write override there also because it's overriding. Let's write override there also because it's implementing a method of a well-known interface. So we write override there also so that it will go and check whether it is matching. Okay. It was anyway checking because it is a necessary method of the interface. Now, it ran and let's see whether we got in ascending order of salaries. Okay. So, yeah. So answer appears to be correct in yes, no, because the salaries are different, it sorted on salaries. Because remember, salary is the first field, only if it is equal, then we go for name. But if it is not equal, then we sort on the basis of salary. Are you able to make out? First, are you able to execute? You should be able to run. Okay, now let's see completely whether it's working. If the salary is same, what should happen? It should sort in alphabetic order of name. Let's see whether that happens. So let's make two people get the lower salaries. Yeah, this is good. So now Chandar should come before Varma because though they have the same salaries, Chandar happens to be lesser than Varma alphabetically because C and V. Okay. Okay, let's confirm that. Let's see the output. Yeah, okay. So now as we expected, Chandar is coming earlier to Varma because their salaries happen to be the same. However, their names are now in alphabetic order, will come in alphabetic order. If salary is same. Is everybody convinced about this? Do you all know how to write a comparable interface? No, yes? I don't want to raise hands or anything, but I'm hoping most of you are able to do it on your own. If you want, I'll pause for a few minutes. Please finish this. This is super important, crucial, because you can't sort a class of user-defined objects. I can't do much with you later. Basic skill itself is deficient. So please finish this. The code is in front of you. If you want, I'll show you the comparable code. It should implement the comparable interface. This is the compare2 method. I've cast it into employee. Please finish. Get it sorted in the way you want it. Then we'll extend this idea further. Even if you have an array of integers, you can define your own way of sorting based on something else. Because these integers may not be integers, they may be some tokens which represent something else. I'll have an example after this and you will see what I mean. So sometimes, very often, you want to change the order of sorting integers because the integers apparently mean something else. So you want to change them in reference to something else. Okay? I will illustrate this with an example later, but I need you to get this very strongly in. Yeah? Okay. Now, we move to the next step. Okay? One more step and we are done with sorting. What happens here? This is called the natural order of sorting employees, which is what? Salary first, name second. Fair enough? Now, let's say, no, that is not how the natural ordering, that is the natural ordering. So when I blindly say sort on employees, this is what I get. I get them sorted based on their salary, and if the salaries happen to be same, then on their names. This is my natural ordering. But employees, should they be always sorted in this manner? Should employees always be sorted in this order? There is one natural order which you have described, but depending on the kind of problem you have, remember, in select statement you write, when you are dealing with, let's say, employees, you write a where condition. What is a where condition? You know select SQL, no? So, you write a where clause. The where clause describes what is your condition, and part of the power of a database is that the flexibility it gives in writing the where clause. You can write whichever where clause, and based on that, data is retrieved or not retrieved, or data is also sorted in that order. You can put an order by choice. Whatever you want in the order by will work. You not want that flexibility even with a list of employees, correct? I'm not strange in asking this flexibility. I want that flexibility to work with employees also, list of employees. I should be able to define my sorting on demand. Keeping this requirement in mind, this is requirement everywhere. Okay? They created the concept of a comparator. Now, there are two ways of writing a comparator. One is the old style, which we used to teach 2-3 years ago. New style, which is using Lambda expressions, which I am going to talk about now. I am going to forget about the old style. So we will bury the old style. We will show you the Lambda style of writing a comparator. So I am going to write a comparator in front of you. Hopefully you will understand. So my comparator now, I want to sort employees based on their employee number. Are you with me? Not salary, not name, nothing. I have a third field, remember, in employees? For some reason, I want to sort it based on employee number. Okay. Now, I am going to write it using a cute lambda expression. You will see how easy it is and understand very easily how to write them. Okay. So, let's change that line 35 a little bit. Collection sort, if I write it like this, it will follow the natural order. But sort takes an extra parameter if you want, it's overloaded. It takes an extra parameter if you want, which can define the comparator, which we are going to write using a lambda expression. Okay. Now, the lambda expression goes like this. A, B, A comma B, A comma B, arrow. Okay. Now, I am going to write it. Now, do you understand A comma B? Two employee objects, A and B, we always write lambda expression using the reference, right? So, A is the first employee object, B is the second employee object. So, how do you compare these two gentlemen? Anybody? These two employees. A represents the first employee, B represents the second employee automatically, because it's a lambda expression associated with employees, used in sort of employees. So, A, B, and now we will say, okay, let me write this, return A dot employee number minus B dot employee number, bracket complete. Yeah. Okay. Do you like this guy? Do you understand a little bit about that comparator now? Do you understand what he's trying to do? I'm telling Java, I want this employees to be sorted, and I am telling you how to compare by passing you these two gentlemen A and B and defining the comparator between them. What is the logic? A dot employee number, the lesser guy in ascending order of employee numbers. That is what this says. In ascending order of employee numbers. So we are saying the data should come based on ascending order, because see, A and B is the first object, B is the second object, same logic. So if my employee number is less than the second employee object, I will get a negative number. So I will come first. I means A will come first. Okay. If I want to put them in descending order, I just have to reverse the logic. If negative comes as a result, it is ascending order. If positive comes as a result, it is a descending order in A to B. Okay. A precedes B. This you will get as you do. Okay, let's give it a shot and see whether we are able to make it work. Yeah. Okay, now the data is sorted in ascending order of employee numbers. Can you see that? You can change the order while adding. It will come in that same order. Okay, let's do that. I think we added 101, 102, 103. So some of you may be surprised or thinking it is coming because of that. No. We can change that to 105 and try. Yeah, that's okay. Just so run it. It will come again 102, 103, 105. Yeah, you see it is coming now in ascending order of employee numbers. I used the comparator using a lambda expression. A and B, two employee objects, automatically they will be treated as employee objects, and I decided what should be the criteria for doing it. Behavior is exactly the same as compared to method, returning a negative for less, equal for equal, and all that. Anybody understood? No? Yes? Okay, let's try and write reverse of what we wrote earlier using this. So ordering first by name, yes, and then by salary. No? Yes? If names are same, then salary, otherwise by name. Okay? So we can write that logic there. Yeah, change that. If A dot name A dot name, name equals, dot equals B dot name then what we should do? Then we return on the basis of salaries. Then return return A dot sal minus B dot sal. After return put a semicolon, else no, then you put a bracket there. A dot sal minus B dot sal, else return A dot name compare to B dot name. Okay, this may look a little complicated, but it is okay. Okay, let's see it working and then I will talk about it. Cannot find symbol compared to A dot name compared to just spelling. Cannot infer type Acha, float problem, int, same, int, cast it into int. The whole thing. We are writing the same logic, but we are writing in a lambda expression, that's all. Okay, we'll just watch it getting corrected and good. So this is first by we can't see it because two names are not same. So we'll make two names same. If the names, it will first sort based on names, and if names are same, then it will do salaries. If names are same, 42, 60, okay. Now see the output. Bigger. Yeah, you see the sorting is done by names first. Now Bilhari happens to be less than Verma, so he came above. Okay, it started by name first. So Bilhari is less than Verma, so he came first. Now there are two Vermas. When the names are same, it's in ascending order of salary. Okay, so that is what we wanted, and that is how we get. Okay, now let's look at the construct a little more carefully. Okay, so what's the construct? What we have done, okay, look at it. Look at line 35 carefully. So sort, we are sorting employee list. AB represent the two employees. A is the first employee, B is the second employee. That is the beauty of lambda. If the names are equal, then we say convert the salaries difference into integer and return it. Else will come when names are different. Then compare it. So if names are same, then do it by salary. If names are not same, the guy with the lesser name should come first. That is what this means. Because it will return a negative number for A versus B. So which will make A come before B. Whenever it returns a negative in that case, in the AB order, it will be in the ascending order. Okay. So this is how I need you to understand this is a general logic. Now if I remove that lambda expression from over there, it will sort in natural ordering, which is in the comparable interface. So I have made the class implement a comparable interface and also a comparator separately in lambda expression. So if the comparable, if I don't give the lambda expression on line 35, I don't give that lambda expression on line 35, then it will sort based on the natural order. If I give this expression, then it will not do that way, it will do it this way. It will override in that sense. So please make this work. And now, I don't know how many of you understood, but I am assuming many of you understood, because I believe that many people here are smart. If you are not understood, it will come over time. Now we know how to create a sorted data, okay, and we know how to create the sorted ordering. Now I will give you an application. It is not easy, it is non-trivial, it's easy categorization, but it takes a little time for you to think. But this is the way you will learn, because unless you learn to think, you are of no use. So we will enable this application, we'll open this application. I'll also, first you read the question. Now I'm going to describe how to do it, then you are going to do it. But I'm going to open that application, read it first, try and understand what we want, then I will tell you what to do. It engages both hash map as well as the list or comparator or whatever. It has both, and it's combining two data structures. So it will be taking a little time to understand, but it's worth it. So we'll open the application, read it first. Day 20, program 1. Okay. Take your time, read it, understand it, and then I'll tell you how to do it. Yeah, you are given a series of numbers with varying frequencies. So something like this. Let's say you are given this series of numbers 1, 1, 2, 2, 2, no? And a 3. Okay, so you are given these numbers. Now you have to produce the order of the numbers in a way which reflects their frequency, how many times they occur. So please do it this way. There are other ways of doing it, but the idea is to familiarize you with this data structure, and perhaps this is an easier way to do it. So first we would build a hash map of the numbers which would record the frequency. So you know how to do that from yesterday's day before session. We know how to take data and record its frequency. We did that using that hash map, get and put. We know how to do that. So you get 1 and its frequency happens to be 2, the number 2 and its frequency happens to be 3, and then you can do 3 and its frequency happens to be 1. Okay. This is how you could do it. Okay. Then you could collect the keys. Okay. Now this is one. This is easy to do. This is a hash map. Okay. Now what you could perhaps do is, now you would want to order this data, that is 1, 2, 3, depending on ascending order of their frequencies. So this is, if you do this and take the key set, correct? So the key set will consist of what? You know, when you build a hash map based on frequencies, you can get a key set. We know there is a method called key set. It will give you a set of keys. So it will give you a set of keys. The keys will be 1, 2 and 3. These are the keys. Now you need to sort this 1, 2, 3. What are the keys? Using what? Now you need to sort these keys using what? Using their value in the hash map. So it is a sorting of integers using a comparator in which the past are A, B. You can write a nice good comparator A, B. And how do you sort A and B? Depending on the frequencies. So you say whatever the hash map hm dot get A and hm dot get B, correct? Using this, you can sort this array of integers or this list of integers. You get them into a list. Don't keep them in a key set, because key set is an unordered group. Take it from the set, add it to a list. Maybe add it to a list. Okay, from the key set, put it in a list of 1 to 3. You get this sorted. When you sort this list, what will you get? In this case, you will get 3, 1 and 2 in this case. Are all of you with me? Because you are sorting based on ascending order of their frequencies. So this will come 3, 1, 2. So this will come 3, 1, 2. Okay. This will come like this, 3, 1 and 2. What you have to do? So this is first step. This is second step. There is a third step. Third step is what? Now you have to produce an output which shows how many times 3 should be, right? So that you go back to this table, use a for loop to add elements to the list. This will give you the frequency. This will give you the frequency of 1, and this will give you the frequency of 2. So in the array list then, because frequency of 3 happens to be 1, you will get 3. If the frequency of 1 happens to be 2, so you will add 1 twice, so 1 and 1. And then because 2 occurs the most number of times, you will add 2 this number of times, 3. Okay. So 2, 2 and 2, and the answer is done. So there are 3 steps to this problem. It's a very interesting problem.
The frequencies are same. Descending
order. Okay. If frequencies are same, then we order them based on descending order of their values. Okay. So B minus A. So you do B minus A if the frequencies happen to be same. That get A, get B. If they happen to be same, then you order them on B minus A. And then go to the table, retrieve the values and do it. I want this method only. I am asking you to implement this method only, so that it gives you a practice on how to do hash maps, sets and sorting. Do it in this way. Do hash map, set and implement it. So if you can implement this, then you are in good shape. You know how to work with these data structures.
Okay, I'll pick one person and see how he has done it, so that,
okay, good. So we are seeing somebody's code, and he has created a class ball with 2 things, number and count, I guess. The ball number and the ball count. Number is number and count is the frequency. That's a nice thing to do, that one at the top. Okay, now, so we have 2 variables in that ball. One is the number and the count. Now let's see the code. Okay, so he's creating a list of balls because he keeps track of both number and count. And that, can we make it a little bigger? And that is what happens on line 59. Good. Then you create a hash map of integer and integer, which is also good. Then you go through all the data. Int I equal to 0, I less than n, I plus plus. Now we have all that data in a hash map. I think most of you will know how to create that hash map. It is just going through the numbers, checking whether on the key, if that key doesn't exist, the value is 0. And if the key exists, this is last class, we are adding 1 to the frequency. See that, put x, y plus 1. So that is adding 1 to the frequency. So at the end of that line, or at the end of that loop 65, what does this guy achieve? He achieves a table, a hash map, where against every number its frequency is recorded, which is the good part. So now these numbers have to be sorted based on their frequencies. The frequencies are there in the hash map, and based on that these numbers have to be sorted. So they should not be sorted by their value, they should be sorted based on what their frequencies are, correct? So it is the frequency which should be used as a criteria. Frequency is available in the frequency table, in the hash map. So now you go to the each entry of the hash map, very good. Well, we can do it that way or whatever. So, okay. So what he is doing is, okay. It can be done this way or it can be done other way also. He is going right now from the hash map and adding the elements to the list. L dot add new one. Oh, he is creating a ball with that key and that value. Very good. So he is creating a key value and he is creating a ball object with key and value. Very good. So now just like employee objects, the ball objects are getting added to the list based on what criteria? Their number and that frequency. The value and the frequency. Very good. Then collection sort. Now is sorting the data. L is the list. Based on what criteria? If the number is equal, if A dot C is equal, if the frequency is equal, A dot C equal to B dot C. So if the frequency happen to be equal, then it is in descending order of the number itself. So if two numbers occur with the same frequency, then it is the descending order of the number. So if two numbers, let's say 4 and 5, have the same frequency, let's say 4 occurs 10 times and 5 occurs 10 times, then it should come in descending order. That means 5 should come first, 4 should come later. So if frequencies are same. So you see that is a logic he has written very nicely. If A dot C, that is count, is equal to B dot C, that is the count is same, frequency is same, then return A dot C minus B dot C. Then return B dot number minus A dot number if it is same. Else it is the return of A dot C minus B dot C, ascending order of frequency. The one with the lesser frequency will come first, the lower frequency. No? The one with the lower frequency comes first. That's what we wanted. Okay. So then now he goes through each ball and now it is all sorted. So he goes through each ball and writes one more loop, which is the number of times it occurs, and adds it or displays it in the output. Wonderful, actually. This is very good code. Very good, excellent. No, this is fine. I wanted this. I know there are other methods, but this is better. We wanted you to understand how to use hash map. Okay. Very good. So let's see any other. Acha, this is another. Okay. Okay. Let's see this. I am assuming, hoping, believing that it is honest. Okay. Because there is no point being dishonest. No. What is the use? Okay. Let's see how he has done. Map, integer. No, let me start in the beginning. Next int, Arraylist, map of integer and integer, hash map. Then I think an array, I don't know why array is needed, but okay, for the output maybe array is needed. So for int I equal to 0, I less than n, he reads the number, puts them into a list. Then, then he goes through the list of numbers and adds them to the array. Okay, L dot get I. Okay, I will keep that array for a moment aside. H dot put L dot get I. Okay, array keeps the frequency. Well, we don't need that. We can keep the frequency using the hash map itself. So let's say the hash map gets the value and gets the frequency. Okay, that you have done using an array, but you don't need it. Fair enough. Don't do it with an array though. A hash map itself can keep a frequency better. Okay, now let's look at your sort. A, B, get A, get B. If the frequencies are same, then descending order. else. Okay, this is a good sorting, good sorted order. Come down, come back. Good. This part is very good. For int I equal to L, you have got all the values in that array and you are sorting it. Acha, based on that. Okay, even this is fine. This will also work. Yeah, you are sorting it based on its frequency. Fair enough. Who is this? Good. This is good. We'll look at one more and probably stop. Yeah. This is third? Okay. Okay. Who is this? Let's look at the code. I don't know whether you need a tree map. Probably you don't. Okay. So the first part of the code makes a map. Okay. First produces a map. Then the data gets sorted based on occurrence, which is also okay, which is what we have seen earlier. This is the Lambda function for sorting data. Come down. ठीक है ना? Sorted data. Then he gets I, and what is goes through the array, prints the number, then prints space. Okay. Anyway, the data gets sorted based on P. P, everything is added to P, is it? Every number. Okay. This is also fine. But among all the three approaches, what do you think is the better one? The last two approaches are similar. Who is this? Satish, somebody? Yeah, okay, good. Among the three approaches, which is the better approach? All three are working. First one, yes, I agree. First one is better because it creates an object called whatever, ball. Was it ball? Yeah, which keeps the number and the frequency and then does sorting based on that. Given a choice, I would prefer that approach because that quantifies the count into 1 and sorts based on whatever the criteria on I or whatever count was C and some other variable which he maintained, N, and then it does the sorting and then based on that creates so much output. Okay, so that I would prefer that. I am not saying anything against the other two, they are also good. Okay, so the creation of an object was a very good step and I think that is good. That indicates a more evolution in thinking, coding and moving forward. Okay, okay, we'll stop here.